Gordon Current Science and Technology stage. My name is Georgia. I use she, her pronouns. I'm one of the many educators here at the New Science. And I'm glad that you're here for our afternoon science snapshot, where today we're going to talk about what's up in space. So since this is the Current Science and Technology Center, we like to bring up some current news items from astronomy. So today I have 3 stories for you. The first one, we're going to talk about the Vera Rubin Observatory. Has anyone heard about the Vera Rubin Observatory recently? A couple of you? Okay, yeah. And then we're going to talk about the sun, because I like the sun. And it's doing some pretty cool things right about now. And then lastly, very quickly, I'm just going to show you at the end a couple of things you can look for in the sky tonight if you're in this area. All right? So to start, let's talk about the Vera Rubin Observatory. This is an enormous observatory, a brand new enormous observatory. It is in Chile, and it's this huge camera and huge telescope way up on a mountain. And we're talking about it right now because it actually released its very first images yesterday. So we're going to look at 3 of them in just a minute, and then I encourage you to go look up this telescope for yourself and to keep track of what amazing images it puts out. So the Vera Rubin Observatory, it has this name. It's named after Vera Rubin, who was an American astronomer. She studied she's most famous for her work on studying how galaxies move and realizing that based on how these galaxies are moving, there must be matter in the universe that we can't see. And this is what we call dark matter. So actually most of the stuff in the universe is made up of dark energy or dark matter, and this is stuff, we basically call it this because we don't know what it is. But she found that galaxies were moving unexpectedly, and that this confirmed that there has to be something else out there that we are not seeing that's not emitting light. And then she also was a big influence in paving the way for other women in astronomy. There's a fun story that when she was working, there's a telescope in Mount Wilson Observatory, and at the time they generally didn't allow women to use the telescopes. And one of the excuses was that they had no women's bathroom for them. So she was working at that observatory and she wanted to use the telescope. So she went up to use the telescope, and the people there, the operator told her, well, you have a limited amount of time because we have no women's bathroom. So she cut out a little paper skirt and taped it to the person on the bathroom door and said, now you have a women's bathroom. And so there's some other stories like that where she really was a kind of a big influence for a lot of women going into astronomy. All right, so back to the telescope then that carries her name. The Vera Rubin Observatory, like I said, is in Chile. It's on this really big mountain in the Andes Mountains called Cerro Pachon. So it's in a desert. It's really high up. It's really dry air, which means it's really clear skies. So this is why we build telescopes on mountains. We want to get through as much of the atmosphere as possible because the atmosphere makes the stars look blurry. So the higher and the drier, the better. And this telescope has been, the idea for this observatory came about in the 1990s. And then in 2010, it was marked as a priority to build. The construction on it began in 2015, so it's taken 10 years to build this telescope. And that's because it has a lot of really new technology. One thing is its enormous camera. It has a huge camera. Its camera weighs more than 2,000 kilograms. It's really heavy, and it has a really wide field of view. So the whole point of this telescope is to take pictures of the night sky, and it's doing what's called the LSST. I'm forgetting the acronym now, what it stands for. But it's basically a survey of the night sky. It's looking at the entire southern hemisphere, and it will cover the entire sky of the southern hemisphere every 3 days. So that way you can see what things change over time. And to do that, you need a really wide field telescope in order to cover that much space. And then in order to hold this ginormous telescope and camera, you need this big sort of mount for it that helps it move. It also holds the filters that go in front of the telescope to determine what type of light images it's taking. So moving on to the light then, let's look at what can this telescope see? Because there's a lot of wavelengths of light that we can't see, right? We only see visible light. There's a lot of other types of light out there. The telescope, the Vera Rubin Observatory telescope, has 6 different filters, and so it can actually see the whole visible spectrum, everything we make it so that we can actually see these pictures. So let's look at a couple of these pictures. Like I said, they were released yesterday, so it's pretty exciting and new. And since this telescope is meant to do large sky surveys, some of their pictures are these enormous swaths of space. So here's one of the first ones they released. It's a galaxy cluster. And just take a minute to see how beautiful this is, right? This is a patch of sky that, if you were looking at it with the naked eye, would look completely empty, all right? It would look just dark. But if you look at it with such an enormous telescope, you can start to see really cool details. You can see the spiral arms of some of these galaxies. All of these dots behind, all these small dots, they're also galaxies that are further behind, further away. So the different colors also are from taking it in different filters, and then we can learn a lot about what makes up these galaxies, how they're moving, and how far away they are. So this is going to teach us a lot. The other really important job of this telescope, the other cool thing it can do, is it can see asteroids and supernovae. So it can see things that move. Because remember, it's taking a survey of the whole sky every 3 days. So a supernova is when a really big star explodes. So it's really bright, but for a short amount of time, which means that if you didn't happen to look at it when it exploded, you would miss it. This telescope would see it was there and then would see it was gone. And so would be able to alert other telescopes to go look at that area or just have that data to be able to compare. And asteroids, similarly, you only see them when the light is reflecting off of them in just the right way so that they're moving past your kind of point of view and all the angles work out right. In just 10 hours of imaging, the Vera Rubin telescope discovered more than 2,000 asteroids. In a normal year, with all of the ground-based telescopes combined, we normally discover around 20,000. So in 10 hours to discover 2,000, there's going to be millions and millions of asteroids that this telescope can find and help us track and learn more about, including some that might get close enough to Earth to actually come close enough to potentially hit the Earth or the Moon. So it's good to know where they are, right? All right, and then the last image I want to show you of these first release images is a picture of a nebula, two nebulas actually. These are the Trifid and Lagoon nebulae. And again, just take a second, take it in. It's so beautiful, right? All these colors are coming from those different wavelengths of light. This is a nebulae, which is where stars are born. So this is a big cloud of gas and dust that parts of it are kind of falling in on themselves and creating new stars. And you can see that in some of these brighter areas where these new stars are being born. And keep track of kind of what big discoveries are coming out of this. This is a long-term project, and it's got a 10-year, for right now, a 10-year span to do this large sky survey, where you basically get to have like a movie of the sky over this amount of time. All right, so this was the Vera Rubin Observatory. Let's move on to our second story and talk about the sun, because I really like the sun. All right, I like to be out in the sun. I know it's hot out today, but I still like the sun. So the sun is very familiar, right? This is something we feel its heat. It is the center of our solar system. The Earth is orbiting around it. We see sunrises and sunsets, right? We're pretty familiar with the sun. But the sun has some really interesting things to tell us, some really interesting stories to tell. And because it is so close to Earth compared to everything else out in space, right? We really want to know how it works. So there are a lot of telescopes looking at the sun. The graphic, all right, this is just some of the satellites that have instruments that are observing the sun. So this is a lot of them. I'm going to choose just one here. This is the Solar Dynamics Observatory. This telescope was launched in 2010. It orbits the Earth, and it's constantly observing the sun. So again, a pretty big telescope, not as big as Vera Rubin, but a pretty big telescope. And because it looks at the sun constantly and in different filters, like we talked about the different wavelengths of light, you can look at different wavelengths of light at the sun, you get some pretty cool pictures of the sun. You can look at all these different wavelengths. And eventually, if you look at enough of these pictures over time, you start to notice there's some patterns, all right? So sometimes the sun is low activity. That means that the surface of it looks kind of smooth. It's not super bright looking in these telescopes. The actual brightness of the sun doesn't actually change that much. But we don't have these bright spots on the sun or like solar flares or protrusions coming off the sides. And then sometimes it's high activity where the surface of the sun looks like it's all getting mixed up. There's these really bright spots. And so you see some low activity, some high activity. So I have a question for you all. All right, this is a picture of the sun today from the Solar Dynamics Observatory. On their website, you can actually go and see pictures of the sun every few hours. They update it. Raise your hand if you think this sun looks like it is low activity. All right, raise your hand if you think like this sun looks like it's high activity. Yeah, it's pretty high activity. It's pretty high activity today. This is lower solar activity. There are fewer sunspots. At solar maximum, there are more sunspots. We are currently at a solar maximum, right around a solar maximum. And so there are more sunspots. There's more swirling around on the surface. There's more of those bright spots. So not only can you see the sun with these space telescopes, you can see the sun from Earth, of course, right? You don't want to look directly at the sun with your eyes. That would be not good for your eyes. But there are a couple of methods that you can see it really well from Earth. One is you would point a telescope at the sun and project that light onto a piece of paper, and then you could see the sun kind of close up that way. Or if you have a solar filter, you can use that on the telescope as well and look directly at the sun through the solar filter, and that would be safe. Now, people have been looking at the sun and looking at these sunspots. This is kind of what it would look like through a telescope from Earth for a really long time, for as long as there have been telescopes. All right, so this is a picture, this is a drawing by Galileo from 1613, where he was projecting an image of the sun onto a piece of paper. Galileo is pretty common, famous name, right? But I want to tell you a story about someone else who I didn't learn about until fairly recently. Her name is Hisako Koyama. She was a Japanese astronomer and a solar scientist. She graduated from high school in Japan in the 1930s, and she worked at the National Museum of Nature and Science in Tokyo. But she really loved studying the sky. During World War II, when there were blackouts, during air raids, everyone had to turn off all their lights and be really dark. She would sneak outside to observe the sky and keep track of it over time. And then she turned to observing the sun specifically. So she would project an image of the sun through a telescope onto a piece of paper. She had her own system of measuring and drawing the sunspots and other features of the sun. And she did this really, really consistently. She went and observed the sun every single day for 40 years. All right, so that's a long time, right? That's a big span of time to observe the sun. But every day that she could see the sun for 40 years, she went and observed it. And with data like that, with information like that, you could count the number of sunspots and see how that changes over time. With her work and a lot of other people's work together, we can start to make a graph. So along the bottom is the year, and up and down is the number of sunspots. Anybody notice anything about this graph? What kind of shape does it have? Yeah. It goes up and down. Exactly, yeah, it goes up and down, right? It goes up and down. So we go to periods of hardly any sunspots, that's at the bottom, and then to lots of sunspots, that's the upper part. And this cycle happens every 11 years. I don't know why it's every 11 years, but it's very consistently every 11 years. We go from a solar minimum to a solar maximum and back to a solar minimum. All right, so this part is some of Koyama's observations, right? And then if we zoom in a little bit closer to now, we can zoom in on this section. And these are the records of the sunspots over the last several years. You can see right now we're at 2025, right? We're at a peak. We're at a point of high sunspots, lots of sunspots, so we're at a solar maximum. And we care about a solar maximum not because it really changes our day-to-day lives, right? The sun is not closer or brighter or hot. It just has more activity happening on the surface. But that can affect the Earth in that it causes more space weather. So space weather is when material from the sun that gets ejected off of the sun gets to Earth and interacts with the Earth's magnetic field. And this can cause a lot of things. This can disrupt satellites. It can disrupt communication, radio communication on Earth. It's dangerous for astronauts on the space station. It can be higher levels of radiation for them. And it can also do some pretty cool things, which is that it causes the aurora, the northern lights or the southern lights. That kind of glowy light in the sky. So during a solar maximum, here's a few things you can expect during a solar maximum. One you can expect more sunspots. This is a picture from today, but in general, there's more sunspots during the solar maximum, and sometimes, probably not today, but sometimes they are big enough that you actually don't need a telescope to see them. When afterwards, come talk to me, you can use solar eclipse glasses to safely look at the sun, and some of them you can actually see with your naked eye through the glasses. Don't look just with your naked eye. All right, and then during the solar maximum, there's also more and bigger solar flares. Like I talked about, this is what's causing the space weather. And because of that, there is a potential to see the aurora closer to home. So several times over the last year, we've actually been able to see the aurora from here, from Massachusetts, from Boston, even through the light pollution of Boston, which is pretty amazing. I haven't seen it yet. I keep missing it, but I'm hoping it'll come up again, because we're going to be over the next year or so, 6 months to a year, we'll still be in this solar maximum period. I have a QR code there if you want to have a prediction for solar weather. There's a website run by NOAA that will tell you over the next 2 days how likely it is to see the aurora close to you. All right, and then finally, to wrap up today, I want to leave you with one thing that you can go do tonight if you want to. So from Boston tonight, around 10 o'clock, because it's summer now, it gets dark really late, you guys stay up a little bit later, but around 10 o'clock, if you go outside, here's a couple of things you can look for. Basically, straight up, you will find the Big Dipper. Right, this is a pattern of stars that has 3 stars in kind of a curved handle and then 4 stars in the cup area. If you're having trouble finding it, you can look from the north. So the front part of the cup part points towards the North Star. So it's always kind of rotating around the north. And then the other thing you can look for, which I think is pretty fun, is this. If you're facing east, so you're facing away from the sunset, you're facing east, one of the brightest stars you can see is going to be Vega. All right, Vega is in a constellation Lyra. It's this really bright star here. And if you look around a little bit, it might take a minute, but if you look around a little bit, there are 2 other stars nearby, a little bit below it, that are also quite bright. Their names are Deneb and Altair. All right, and these stars, between the 3 of them, they form the summer triangle. So this is not a constellation. This is what's called, we call an asterism. It's a collection, it's a pattern in the sky that's not its own constellation. But between these 3 is the summer triangle. We mostly from here see this in the summer, so it's a pretty timely thing to go look at right now. And it's just kind of fun to see this giant triangle in the sky. You can also try and see, if you're somewhere really dark, you won't be able to see it from Boston, but if you're somewhere really dark, the Milky Way goes through this summer triangle as well. Okay, I'm going to leave you with a QR code. If you have any interest in following up on Vera Rubin, or predicting solar weather, or making your own stellarium chart, sky chart, and seeing what's in the sky tonight, you can follow this. I am missing a couple links, and I'm going to update it right after this. So scan it and then save it, all right? And I'll update it in a few minutes. Thank you so much for coming. Let me know if you have questions, comments, stories. Come talk to me. Otherwise, enjoy the rest of your day.